All right, today we are diving into one of my favorite design patterns, one that is just wonderfully elegant for solving a super common coding problem. We're talking about the decorator pattern. We're going to see exactly how you can add new features to your objects without getting stuck in a tangled mess of code. So you've been there, right? We all have. You have a class, it's working perfectly, it does its one job really well, and then you get a new requirement. You need it to do something extra, maybe some logging, or you need to add a new kind of notification. What's the first tool most of us think to grab?
Yep, inheritance. And look, inheritance is great for what it does, but it can lead you straight into a trap. Let's say you need a notifier that sends emails. Okay, you make a subclass. Then you need one for SMS, another subclass. But what if you need one that does both? And then one that does both and adds Slack notifications? You see where this is going. You get what's called a class explosion, and it is a messy, unmanageable nightmare to maintain.
But what if you could just add these features on the fly? Mix and match them whenever you need to. Well, thankfully, there is a much more flexible way to get this done. So let's put a formal name to this headache: the class explosion problem. It's what happens when you try to cover every single combination of features just by using inheritance. It's super rigid because you have to define all these combinations up front when you're writing the code. And you end up with a crazy number of classes that are all tightly connected and just awful to change later. The solution is to change how we think about the problem. Instead of creating a whole new type of object for every feature, we're going to dress up the object we already have. This is the main idea behind the decorator pattern. Just think of your original object like it's a person, and every new feature is just another piece of clothing you can put on them. And here's the official definition for you. The decorator pattern lets you add new behaviors by putting your objects inside special wrapper objects. Now, the key is that these wrappers have the exact same interface as the object they're wrapping, so from the outside, your code doesn't even know anything is changed, but on the inside, they're secretly adding new functionality. Let's just walk through that analogy. You start with your base object, our person. Feeling a little chilly? You wrap that person in a jacket decorator. Now they have the warmth behavior. Need some sun protection? You wrap the person who's already wearing the jacket in a hat decorator. You can just keep layering on these wrappers or decorations as you need them. It's all dynamic. Okay, so the analogy makes sense. But how do we actually build this thing in our code? Let's take a look at the technical blueprint. It's really just a few key pieces working together. So let's break down the players here. First, you have the component. Think of this as the abstract idea of a person who can wear things. It's the common interface they all share. The concrete component is the actual person you're starting with. The base decorator is like the abstract concept of clothing. It knows it's supposed to wrap a component. And finally, the concrete decorators are the actual clothes. The jacket, the hat, each one adding its own specific feature. Now, this slide right here is the key to everything. This is the big aha moment. With inheritance, you extend behavior at compile time. It's static. It's set in stone when you write the code. But the decorator pattern uses composition, and it lets you extend behavior at runtime. This is completely dynamic and so much more flexible. You can literally create new combinations of features while your program is running. And this quote just says it all, doesn't it? The most important insight here is that you're adding responsibility to an individual object, not changing the entire blueprint for a class. That is a huge, powerful shift in thinking. Okay, theory is awesome, but let's make this real. Let's see how this actually works with some code in a practical example you might actually run into. So imagine you have a class, and its job is to write data to a file. Super simple, it works. But now you get a new requirement. You need to add compression to save disk space. And for security, you also have to add encryption. Now, if we try to use inheritance here, we'd be right back in that class explosion mess we talked about. So instead, we're going to build a stack of objects. Our base component is the file data source. It just knows how to handle the raw data. Then we'll layer a compression decorator on top of that, and an encryption decorator on top of that. Each piece has one single clear job. So let's trace what happens when you want to write some data. Your client code just calls write data on the outermost wrapper, which is our encryption decorator. It does its encryption job, and then it delegates the call down to the object it's wrapping, the compression decorator. That guy does its compression thing, and then passes the call down to the base file data source, which finally writes the fully processed, compressed, and encrypted data to the disk. The call just tunnels through the layers, and each layer adds its own value along the way. And the real beauty here is how modular this is. You can assemble these behaviors in any order you want, and you can do it all at runtime. Just need encryption but not compression? Easy. Want 2 layers of encryption for some reason? No problem, just wrap it again. It's that flexible. So now that we see how powerful it is, when is it actually the right tool to reach for? Let's get into the final verdict and take a look at the pros, the cons, and the best times to use it. You should be thinking about the decorator pattern anytime you need that runtime flexibility. Adding or even removing responsibilities from an object without breaking all the code that uses it. It's also a fantastic choice when using a subclass just isn't practical. Maybe you're dealing with a final class, or you just need an insane number of subclasses to get the job done. So let's weigh the pros and cons here. On the plus side, you get that amazing runtime flexibility, you can combine behaviors easily, and you avoid a messy inheritance tree. Each little decorator does one job, which is fantastic for keeping your code clean. But there are trade-offs. The order you stack your wrappers in can really matter. Getting a specific wrapper out from the middle of the stack can be tricky, and having all these little objects can sometimes make the initial setup a little more complex to look at. So really, the big idea here is this. The decorator pattern is the perfect example of that famous design principle, favor composition over inheritance. Instead of making objects that are a certain thing, you make objects that have certain things. It's just a more flexible and powerful way to design software. And that brings us to the end. I'm going to leave you with one final thought. Think about your own projects. Where do you have a rigid inheritance structure that you could replace with a flexible stack of decorators? What objects in your codebase are just waiting to be dressed up? Thanks for joining me.